Good afternoon, everyone, and welcome to WASA Distance Education. This is MBF3C, Foundation for College Mathematics, grade 11, and my name is Marvin. Yesterday, we finished up the work with trigonometry, so sine, cosine, tan, the ratios. We can use those three when we're solving right angled triangles. So a triangle has a right angle or a right triangle. If we don't have a right triangle, we have to use the sine law or cosine law. Sine law, you need a side, or sorry, an angle with the opposite side. You need at least one pairing. And the cosine law is usually used when you have a side angle side. So when you have two sides and the angle between those two sides is known. Or if you know the length of three of the sides and you're trying to determine the measure of each of the angles, then that is what you would use. So that takes care of trigonometry. So now today we're going to finish off this unit by talking about nets, and not talking about fishing nets or anything like that. We are going to be talking about, and again, this is class number 28. My contact information is on the screen, marvin.osmond@nnecschools.org or 807-738-2031 if you want to give me a call or shoot me a text. I'm going to scoot down past this right here. So a net is when we have, so we talked a bit about this yesterday, when we make cardboard boxes. So when cardboard boxes are made in a factory, they're not actually cardboard boxes. They're actually nets or something similar to a net. And they're on a flat piece of cardboard. And then there are going to be places where the cardboard is perforated or kind of indented so it can be folded along lines. And then when you fold it along those lines, you can create a box. And you can actually go to places that still sell stationery, and you can actually buy different shaped boxes that are just pieces of cardboard that you have to fold up to make a box. So that's, I'm going to scoot down past this, and we're going to look at some definitions. We're going to be talking about geometric shapes. And up until now, we were talking about two-dimensional figures. Now we're going to be talking about three-dimensional shapes. So we're going to take a two-dimensional object, like a piece of cardboard, and we're going to fold it to make a three-dimensional object. Okay? So just like in the two-dimensional world where we have circles and squares and rectangles and triangles and trapezoids and hexagons and pentagons and so on, in the three-dimensional world, we also have some things that have special names. So the first one would be a cube. Think about Rubik's Cube. So in a cube, there are, we call them faces. So a face would be basically a side. Could be one of the four sides or the top and the bottom. So when you think about a cube, you have a top, a bottom, front, back, and the two sides. There are six sides, so there are six square faces, we call them. So in mathematics, we call them faces, not sides. So a cube has six faces. Edges would be where two of the faces meet. So we have one right here, two, three, four at the top, and then we have one, two, three, four at the bottom. That's eight, and we have one, two, three, four up the side, so which makes 12. So we have 12 edges, and we have eight vertices. So a vertex is the point, okay, it would be the point, oops, where, and actually in this case, three of the edges meet, or three of the faces meet. So basically the corners of a cardboard box or the corners of the cube are vertices. And there's one, two, three, four, five, six, seven. There's 8 of them. The angles between the two adjacent faces, so between this one and this one, are right angles. So just like the corners in a house, corners in a box, they're all going to meet at 90 degrees. So there is a cube. A sphere is basically a ball. No faces, no sides, no vertices. There are no points. There are no straight lines. I guess you could say maybe one face, but technically there's no faces. All points are located at the same distance from the center. So if you think about it, from the center of the circle to any point on the circle is a radius. So any point on that circle, if you were to measure the distance to the middle of a circle, it will be the exact same measure each and every time. So if you could attach a string to the middle, if you're inside of the circle, and you could attach a string to the middle of the circle and cut it where it touches the end, then it would touch at every point on the sphere inside. The rectangular prism is basically a cube is a special rectangular prism. A cube is indeed a rectangular prism because a square is a rectangle, but a rectangle is not a square. Okay. So in a rectangular prism, we have 6 triangular faces where the opposite faces are equal. Just think of it as a cardboard box. I'm looking at one on my desk right now. So the top and the bottom are the same size and same shape. In other words, they're congruent. The two ends are exactly the same shape, and the two sides are exactly the same shape. So we have 6 triangular faces where opposing faces are equal. We should say congruent, really, but equal is fine for now. We have the same thing with the cube. There are going to be 12 edges and 8 vertices, and all of the angles at adjacent faces are going to be 90 degrees or right angles. Cylinder, a can of soup, can of pop, anything that comes in a can. So a cylinder has 2 circular faces, so the top and the bottom are circles, and the side, believe it or not, is actually a rectangle. So if you were to take the side, so think of a label on a can of soup. If you were to take a X-Acto knife and you were to cut a straight line from top to bottom and remove the label and lay the label on the table, it will lay flat and it would be actually a rectangle. So there's 2 congruent faces. They're going to be circles. Congruent means same size, same shape. They're also going to be parallel to one another, which means you're going to be the same distance apart at all points. And the faces are connected by a curved surface. Now, this curved surface, if it were a label, like I said, can be straightened out, laid flat, and it would actually be a rectangle. Pyramid, we've all heard about the pyramids in Egypt. So a pyramid has a polygon base. So polygon means it could be anywhere from 3 sides, because it's got to have a minimum of 3 sides, otherwise it can't be a polygon. Because if it's only got 2 sides, it can't be closed. So a polygon is a closed figure. So if you think about it, if you have a rectangle or a triangle, you're inside and you can't get out. If you were to draw a line, you can't get out. There's no break. So the pyramid is going to meet the triangular sides. It's going to have 3 or more triangular sides, and they're all going to meet at a point at the top, and that point is called an apex. Okay, so we can have a triangular prism, which is to the right. Sorry, a triangular pyramid. Sorry. So a triangular pyramid would be a regular tetrahedron, which is all off the sides, even the base. So it's got 3 sides that are going to be triangles, and the base is a triangle as well. So there's going to be 4 triangular faces, 6 edges, 4 vertices, and the triangles are all congruent. Actually, they're going to be equilateral, so it means all sides are going to be the same length. And so that in that case, all angles will be the same measure. So each angle would be 60 degrees. So in a pyramid, you could have three sides, four sides. The base, the sides will always be triangles, and they're always going to meet at a point at the top for it to be a pyramid. Could have a five-sided base where you have five triangles, six-sided base, six triangles, seven-sided base, seven triangles, and all triangles will meet at a point at the top. Okay. Then we have a cone. We've all seen what an ice cream cone is. So it's got a circular base, and then we have a curved surface connecting the base to the apex at the top. Okay. So we have right cones and oblique cones. We're not going to worry about too much about those right now. But we'll just talk about mostly the right cones. And then we have triangular prisms. So a prism, if you think about a Toblerone box, or if you know what a prism looks like, is going to have the two ends are going to be triangles, if it's a triangular prism, and then the sides are going to be rectangles. So you got five faces, nine edges, six vertices. Two triangular faces are going to be congruent and parallel, and then you're going to have three triangles, and those triangles will also be congruent. Uh, well, not necessarily, no. Two of them will be congruent, but the third one might not be, depending on the type of triangular prism that it is. Okay, so those are some definitions. So what we're going to look at is nets. So a net, again, would be a two-dimensional. So this would be two-dimensional. These are three-dimensional objects, two-dimensional figures. So we're going to take a two-dimensional shape, and we're going to, if we were to fold it along the lines, and we were to fold this up and we could make a cube. This one is called a cuboid, but up here it would be we would call that a rectangular prism. You don't see that term used very often, cuboid. So again, we would prefer to use the term, or we will use the term rectangular prism because the sides are rectangles. If you fold that end up, that end up, this end up, that end up, and then this piece flips over onto the top, there you have your rectangular prism. If I flip that side up, this up, this up, I get a triangular prism. If I flip the four triangles up, they'll meet at a point in the middle that gives me a square-based pyramid. If I take this side and flip it up, that side and flip it up, and this one and flip it up, I'm going to get a triangular-based pyramid or a tetrahedron. A cone, believe it or not, if I were to cut this out and flip this up, and I were to take these two sides, bring them so that they're together touching, you would actually end up with a cone. Okay. Then we have down here, we have 1, 2, 3, 4, 5, 6. So the base, so the bottom and the top are the same. So in a prism, opposite sides or the ends, so just like in the triangular prism up here, the opposite ends are equal. They're going to be parallel. So the two faces are parallel. And this one here, the two faces are going to be parallel. So I'm going to flip this up. This will flip over to be the top. So the bottom and the top are going to be equal. And then all of the sides are going to flip up and touch each one of these sides up here. So then you're going to get a hexagonal. So six sides is a hexagon. So it's going to have the number of faces, 1, 2, 3, 4, 5, 6, 7, 8 faces. We can also have a hexagonal pyramid. So the base is a pyramid, or sorry, the base is a hexagon. All the sides are triangles, so when I flip them all up, they're going to meet at a point. That gives me a hexagonal pyramid. And the cylinder, flip that down, this up, and then wrap this around the two circles, and you'll end up with a cylinder. Okay, going to end up with a cylinder. So what we have to do now, or what I would like you to do if you are participating, is look at each of the shapes that's going to be in color and then pick out the net out of the three that's to the right that would give you. So which one of these two-dimensional um, nets will give you that three-dimensional object? So what I would do then is I'm going to into here, I'm going to pick my marker. So this is going to be a flip it up. It's going to be a pyramid. That's going to be a cylinder. This is the one right here that will give me this shape. So we'll fold this one up, fold that one up, this one up, this one up, and then this one will flip over and become the top. So the bottom, the top, and the four sides gives me this one. This is a cylinder. So in a cylinder, you can actually look up here if you wanted to. There's a cylinder right here. Now the two circles don't have to be there. The two circles could be, as long as they're opposite each other. It could be here or here. It could be anywhere. So a cylinder, top, bottom, sides. Cylinder. This is a triangular, sorry, not a triangular, a rectangular based prism. Come up here, all the way up here. This would be a rectangular prism. So a rectangular prism. And that is this right here. That right there are the two ends. Back, front, the bottom, and the top. So this is the one right here that will give me that shape. The base is a square and the sides are triangles. Base is a square, sides are triangles. All four sides are triangles. And here, this would be a pyramid. The two sides and two ends are going to be triangles, and we have 1, 2, 3 sides. 1, 2, 3 sides, so there we go. So that is how we would create a three-dimensional object from a two-dimensional shape. Okay? So it's not a difficult concept. I'm just going to erase these now so that when I use it again, the marks are out there. So if you want, actually, you know what? I will leave the check marks there because this is going to be the solution. So that's that one, this one, this one, this one, and that one. Okay. Let's scroll down. I don't know why. So now we have a different one. Now this is going to be a matching. Match each net to its name and 3D representation. First one is done for you. This is all of the sides. So here, so 1, 2, 3, 4, 5, 6. They're all the same size, same shape. So they're all squares. So a square gives us a cube. And when it's folded, it makes that shape right here. Remember what this one is? So it's got a square base, and all of the four sides are triangles. So when we have triangles, and they go to a point at the top when they're folded up, that is called a pyramid. It's got a square base. So this one here is a square based pyramid. And it's going to give us square base pyramid is, oops. Okay, I'm going to redo that. This piece of paper got in my way. Let's do the undo. Okay, so from here, I'm going to come down. Let's do it this way. Square base pyramid. This one, we have 3 rectangles and the 2 ends. So when we have 2 ends that are the same, that is going to be a triangular, and it's going to be a prism. So this would be a triangular prism. So from here, I'm going to come down and come over, and it's this one. This is going to be a, what they call a cuboid or a rectangular prism. So from here, here, that's the one. This one is a, because it's got a triangle and all the other triangles are exactly the same shape, that's a tetrahedron or a triangular base pyramid. Is pyramid because the sides are going to be rectangles and you're going to go to a point at the top. So that's going to be here down to here. And there's only one left, isn't there? So the bases are going to be hexagons, and we have the top and the bottom are the same size, congruent shapes. So it's a hexagonal prism. So that's what you're expected to do in this particular worksheet. So it's basically match the net with the shape with the name. I'm not too concerned about the names right now, but as long as you can visualize the nets forming these shapes over here. So if you can visualize that, you can always look up the names if you want. So now, this one you can, if you have the time, you can actually print this, and it doesn't hurt to do this. Cut them out with a pair of scissors and then try folding them. So we're going to do it visually. We're not going to actually cut them out. It says cut out the shapes below and fold them up to see which one makes a cube. So a cube means 6 faces, top, bottom, front, back, left, right, 2 sides, are all going to be the same size. So if you look at all of these, all 6 faces are exactly the same size, same shape, if you just look at them. When you fold them up, and again, there's more than one way to create a box, or in this case, a cube. Which ones, when folded, will give you a cube? Well, if I fold, this can be the side, that's the side. Okay, I'm just going to put S's there for now. Side, side. This can be the back of the box. This can be the front of the box. This can be the bottom of the box. And this part will become the top. So if I fold it up, fold it up, fold it up, fold it up, and then flip the top part over top of the bottom part, now we have a cube. So in this particular one right here, I can check this one off. Actually, I should have left it there, but this one can and will form a cube. This one, if I fold up, I can make this, say, I can make this the back, the bottom, the front, and the top, keep folding it, folding it, and folding it, but there's no way then I can get to the side because this would just fold over onto the bottom to the side. So this one cannot be a cube. I can fold this up, I can fold this up, but there's no way I can get a top. So this will not form a cube. This one, this can be the side, this can be the side, this can be the bottom, this can be the back, and it's called B again. I'll put back there for this one. That's the bottom, the back, the top, and the front. So this one can and will form a cube. So we can put a check mark this one. This one I can give, this can be one of the sides, but there's no way because these can only fold in one direction. Can fold it that way, I can fold it up or down, but I can't take any one of these and fold to the side to get the matching side for this one. So this one will not be a cube when folded. This can be the side. This one can be a side. Then this can be the front, the bottom, the back, and the top. And then these become the two sides. So this one will indeed form a cube. So I can put a check mark next to that one. That one works. This one, again, because the two of these are on the same side, there's no way of getting to the other side. So this one cannot be. And again, right here we have 1, 2. They're on different sides. So as long as we have 2 on different sides, side, side, top, back, front, bottom. So this one will be, let's get rid of those dots first. This one will be a cube. So again, so what I've done is put it here, and there's the answers right here again. So we got the same ones. We said yes, no, 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 yes, no, yes, yes. So did we get the same thing? Yes, no. Yeah. So we had yes, no, 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 yes, no, yes, yes. And that's what we, same here. Yes, no, 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 yes, no, yes, yes. So that is pretty much it for this particular lesson. Fairly short. And the key question is only 3 of them. So now, based on the information that we've covered today, you should have enough to help you finish off this particular lesson, and it then completes the unit as well. So down here, you'll notice that support question answers, all of the answers to support questions are listed here. So as you're doing the support questions, you can always come down here and check the solution to make sure you are doing things correctly. So now I'm going to click on the Save button. So all of the blue material is new material. Red is solutions. I have this saved as a Word document, and I can save it as a PDF. So if you want a copy of my notes, things that are in here that are not in the package that you would have received, and you would like the additional notes, then feel free to reach out to me, telephone, so you can call, text me, or shoot me an email, and then I will send you a copy of this. And you just let me know which format you want, if you want it in Word format or in PDF format, and I'll make sure that you do get it. So I'm going to save that, close this, and now we're going to move on to the next unit. So the next unit and the last unit is titled Data, Sampling Data, or Data Management. So this unit is all about data management, or another word for statistics. We're going to be looking at statistics and how statistics can be used, and they are used a lot in the real world, and I mean a lot. If you watch any news, you'll see them on the news all the time. People doing research will use statistics a lot. So it's a fairly large field of study, and there's a lot of work out in the real world if you are a statistician as well. So let's keep, I'm going to scroll down because the definitions are in here, and I don't need to read those to you. So again, blue is new. So I've added uh, definitions which are very similar to the ones that are already uh, in the package, but are slightly different and maybe offers a little bit more details. And it's up to you how you use this information. So first thing first, when we're looking at statistics, there are certain terms we have to become familiar with. One of them is a population. Now, whenever someone hears the word population, they automatically think people. And that could be something that statisticians are studying, but it doesn't have to be people. It could be animals. I might be interested in how many moose there are in northwestern Ontario. It could be fish, a specific type of fish, walleye, pike. It could be trees. What type of trees are in this section of Ontario? So there's whole could be insects. You notice anything a population could be. So a population refers to the entire group of individuals, items, or data that you want to study or draw conclusions about. So usually when we study something, we we're studying so we can make a or draw a conclusion or make an inference. Otherwise, why would you just study something for the sake of studying? You study it, you have a purpose for your study, there's a reason for what you're doing, and you're trying to determine some information about a population so then you can do something. So you might be interested in how many people in northwestern Ontario have diabetes, for example. So once you have the information, and you might want to break it down by age group, by sex, male, female, by location, by community. And once you've got all of the information in front of you, then you can start making some decisions. Maybe you only have a certain amount of medication to go around, whereas best to ship that medication. So if you are studying the average height of grade 10 students in Ontario, the population is all grade 10 students in Ontario. So if we're interested in what the average weight and height are of grade 10 students in Ontario, there's an awful lot of kids in Ontario in grade 10. But that would be the population. Now, I don't have the time or resources to check everyone's weight and how tall they are of every student in Ontario. Just not feasible. It's just too many. We'll be in the millions. So, what statisticians have done is they've created a way of looking at some of the people in that population and then drawing conclusions based on some of the information. So what they do is they sample the population. So a sample is a smaller group selected from the population and is actually observed or analyzed. So if I'm interested in how tall and how heavy people are, or in grade 10 in Ontario, and I can't ask everyone, then I'm going to select a certain number of them, not all of them, maybe only a small percentage of them. And then once I've done that, I can use that to make inferences about the population. Okay. So I can say there's several million grade 10 students in Ontario, and I'm only going to, let's say, work with 1,000 of them. And then based on that information from those 1,000, in this case, we're looking at 200. They say you might select 200 grade 10 students from 10 different schools in Ontario as your sample. So you could pick any 10 schools in Ontario and then pick 200 students from those 10 schools. And then you can infer that if everything else is the same, that you should get roughly the same number of people in the other schools with this information. And then you can say, well, okay, based on this, we can say across Ontario, we can say this is the average weight and average height of students. Another common one is when there's an election. You hear a lot about polls. And polls are where a pollster will call maybe 1,000 people, ask them how they would vote in the upcoming election. And then based on that information, they can predict who will win the election. Now, a lot of times they are correct, but they're not always 100% correct. So when you're doing the sample, you have to be very careful on how you select the sample. So we're going to look at some types of sampling methods. And so the probability sampling is each member as a known chance of being selected. So simple random sample means that every member of the population has an equal chance of being selected. That's what random sampling means. So a simple one might be you put everyone's name in a hat. So if there's 20 people in the room, you put all 20 names in the hat. Everyone has the same chance of being selected. Your name is there once. Now, if you put everyone's name there once, and I put my name there 20 times, then that's not random because everyone else doesn't have the same chance of being selected that I do because their name is only there once and mine's there 20 times. So random means everyone has the same chance of being selected. So once one name per person goes into a bag and you pick a name. That's a simple random sample. A systematic sample would be if you were to list all of the individuals on a sheet of paper, piece of paper, right? All the names maybe in alphabetic order by last name, by first name, or pick some other um, uh, stat or some other feature to create a list. And then you're going to pick every nth person. So let's say there's 20 people and you want to select 5 people, then you're going to select the fourth person, the eighth person, the 12th person, the 16th person, and the 20th person. That will give you 5 individuals. So every fifth person or every fourth person, or if it's a large group, 1,000 students, you're going to select every 10th student. So number 10, number 20, number 30, number 40. So all of the individuals will be numbered from 1 to 1,000. You're going to pick number 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and so on. Stratified sampling. So stratified sampling would be you're going to divide the population into subgroups based on a characteristic, and you're going to random sample so many from each group. So for example, you might want to divide all the high school students by grade 9, grade 10, grade 11, grade 12. There may be more students in one of those grades. So what you need to do is you need to determine what percentage of the students are in grade 9, what percentage are in grade 10, what percentage are in grade 11, what percentage are in grade 12, and then that percentage will be multiplied by 25, so 10% times that by 10%, 15% times 25, 18% times 25, 16% times 25, whatever the numbers are, and that will tell you how many people from each grade would be selected and sampled. That's a stratified sampling. Or you could stratify by courses, math, English, chemistry, and so on. You could do it male, female. So there's a number of ways you could do it, but then you have to make sure you got to do the math and get the percentages right. And then you select that percentage of those individuals from the total number that you are going to be sampling. A cluster sample would be the population is divided into clusters. So for example, you could be looking at schools in Big Trout Lake, Bearskin, Kingfisher, and all of the communities in that area. And then you're only going to select some of those individuals, some of those clusters, some of those communities, and you're going to interview people in each of those clusters. So you can't do all, let's say 25 communities, but maybe you can do five of the clusters. So you maybe do five schools and then leave out the rest. That will be a cluster sampling. That's different than systematic and it's different than stratified. Stratified, you're going to work out the percentages for each grade, and that percentage is multiplied by 25 to determine how many people in each grade will be sampled. Whereas in clusters, you're not doing that. So this was not, you're only going to do so many people in so many of the schools, just to make it simpler. Then there's other ones as well, non-probability statistics. So these you might not have the same chance of being selected. So a convenient sampling would be choosing individuals that are easiest to reach. So for example, you're going to survey students in your own class, and you're not going to ask anyone else in the school. So for example, if you're looking at how tall and how many people are in grade 10, and maybe there's five grade 10 students, or sorry, five grade 10 classes in your school, and you're only going to ask students in your class and not the others. So it's not really that that random. Okay. Voluntary response sampling, that would be you pass out a survey in class and ask for people to complete it and submit it to you later. Now, in those cases, not everyone is going to respond. Not everyone will complete the survey. So, you'll see a lot of surveys online where they ask you to complete a survey. Some people will do it, a lot of people won't. Judgmental sampling would be if you're studying a specific topic that may require some expertise, then you might only research or survey participants based on their knowledge or expertise of the topic. Okay, so if we're talking about education policy, uh, then you're probably going to stick to principals of schools, and you're not going to go talk to students because students probably would know about the policies. And then quota sampling is you have to have so many per uh, group. So you want 50% male, 50% female. You have to have 50-50. Okay. So some of these are, uh, they're here by name, um, but I don't expect you to memorize them. Some of them are more common. So you'll see the simple random sample used quite often, and that's the most random. If there's any way of doing a simple random sample, that's probably the one to use. Systematic is not bad. Stratified is not bad either. Probably, if I were to rank them, I would probably rank this one second, that one third. Cluster, not bad, but you're eliminating some of the schools, for example. Okay. So the key concept here is that a sample should accurately represent the population to make valid conclusions. Random methods generally give more reliable results than non-random ones. So what they mean by representative of the population or represent the population, if I'm interested in grade 10 students and I interview some people in grade 9 and some people in grade 11, maybe some people in grade 12. Well, then people in grade 9 and grade 11 and grade 12 are not part of the population. So your sample doesn't represent the population. So you should only be interviewing grade 10 students if that's what you're interested in. Grade 10 students, that's your population. So your sample must come from your population. So you can't be picking people outside of that group. The more random it is, the better the results. Okay, so throwing names into a hat, picking names, more reliable than just standing at a door to the cafeteria and stopping people as they walk out and say, can you complete the survey? Because now you might just talk to the first 20 people that come out. They might all be friends, might all be in the same class, and you don't talk to anyone else. Not a great way of doing it. Bias is a tendency or preference, sometimes conscious, sometimes unconscious, that affects judgment or decision making, often leading to results that are unfair or unbalanced. So, for example, I'm a Montreal Canadiens fan, and I am going to interview a bunch of people at the school to see, what people's favorite teams are. But I go to a group where I know most of them are my friends, and I know that most of them are Montreal Canadiens fans. Well, that's going to be biased because not everyone's got a equal chance of being selected, and I pretty much know what the answers are going to be. So bias. Now, sometimes it can be unconscious. You may not realize what you're doing is being biased. So to eliminate bias, it's best that your sample be completely random. And that's why they have rules and procedures to follow when you're sampling a population. Okay. So bias, we're more concerned about the statistic part. Um, you get a systematic error that causes certain results to be favored or over others. So in other words, you get an inaccurate conclusion. So for example, like the election, if I'm trying to determine who's going to win the next election, and I phone all the people that are on the conservative uh, party website, then I'm pretty sure they're all going to vote conservative. So if I only survey those, then the results are going to be biased. So I might predict that the conservatives will win the election, and that I might not be right because I only interviewed people that I know would give me the answer that I was looking for. Okay, so you need to guard against that so we don't end up in a situation like that. So here's a sample problem for you to take a look at. Read each scenario carefully and identify which sampling technique is being used by writing one of the following: simple random, systematic, stratified, cluster, convenient, voluntary response, judgmental, or quota. So the 8 that we looked at earlier up here, so these 4 right here, and these 4 right there, so 8. So each one of those, and there's 8 scenarios here, each one of these will, each one of those right here fit in one of these blanks. So you have to determine which one goes where by reading the information. You might have to go back up here. So for example, a researcher selects participants who are known experts in environmental science to discuss climate change. Well, which one of those, if you scroll up here, would that be? So the researchers select participants based on their knowledge or expertise. That would be judgmental or purposive. So judgmental would go in here. So I'm going to actually do this one for you now. And judgmental. So you simply put that in there. I'm going to tighten this up a little bit here. So it looks the same. Oops. And I'll just make the underline all red so it all looks the same. There we go. So the first one is done. And that's about as much time as we have for today. So tomorrow we will finish off this particular um, sample problem. And then we're going to move on to the very next lesson. That this will be it for this particular lesson. And then we're going to move on to lesson number 17. So we're getting near the end of the course. We're at 17, is only 20 lessons in total. So we'll stop here for today. and we'll pick up again tomorrow at the same time. Bye for now.